With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi guys, today we are just going to see one more problem. H2O2 plus 2Ki, 40% of field they have mentioned, and will give I2 plus 2 KOH, and H2O2 plus 2 KMnO4 plus 3 H2SO4. They have given us 50% yield, will be giving potassium sulfate and manganese sulfate, O2 and my water. They have given 150 ml of H2O2 sample was divided into two parts they have given, and the first part they will be treating with the Ki, and the formed KOH requires 200 ml of M/2H2SO4 for neutralization. The other part with KMnO4 yields 6.74 liter of O2 at 1 atmosphere and 273 Kelvin, that is at STP. Using percentage yield indicator, they have asked the volume strength of H2O2 sample used. So let me calculate first. So what is that the molarity of my formula is? The molarity formula will be equal to my number of moles divided by my volume in liter. So I come again, molarity will be equal to number of moles divided by volume by liter. So I have to, by using the formula, I am just going to calculate the moles of H2SO4. The moles of H2SO4 they have given is M/2 into my H2SO4 they have given 200 ml. So I can have 200 ml, which is I have to convert it into liter, that is 0.2 will be equal to, cancelling it, 0.1 molar. So the next step will be my moles of H2O2. So the moles of H2O2 used in the first reaction, I can write here is that is the moles of KOH divided by 2 into 1 by 0.4. I have mentioned for 1 mole of H2 and they have given 40%, so I have mentioned 0.4 here. So 0 moles of KOH I have to calculate irrespective of the formula. The moles of KOH will be equal to my 0.2 molar. So I am writing that moles of KOH will be equal to 0.2 molar. The next step is moles of produced O2. Moles of produced O2 will be equal to that 6.74 liter, which is given in the question, divided by, at STP they have given, so I can write very well 22.4 will be equal to 0.3 molar. So I have calculated the moles of O2 produced. Therefore the moles of H2O2, the moles of H2O2 in second part of the reaction. In second reaction, I can write very well that 0.3 divided by, that is the moles of oxygen into 3 moles of oxygen they have written 0. So it will be equal to my 0.2 molar. So 0.2 molar I have written. The next step will be my total moles of my consumed O2, H2O2. Therefore the next step will be the total moles of consumed H2O2 will be equal to the first part and the second part. I am just going to add here. The first part, what is the value that I have calculated is 0.25. It seems by calculating this, I can have here 0.2 divided by 2 into 1 by 0.4 will be equal to 0.25 molar. So 0.25 plus this 0.2 will be equal to 0.45 molar. I have calculated the molarity of H2O2. The next one is I'm just going to calculate finally the moles of molarity of H2O2 will be equal to 0.5 0.45 divided by my 15 ml. I am just going to convert it into liter. That is 0.15 be equal to 3 molar. So finally I have calculated the molarity of H2O2. The next step is my volume strength of H2O2. The volume strength of H2O2 is given by the formula. The volume strength of H2O2 is given by the formula 11.2 into my molarity, that is 11.2 into my molarity, that is 3 will be equal to 33.6 volume. So I came to a conclusion that the volume strength of H2O2 is 33.6 volt. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.